Welcome to exercises solution of mathematics for class 9. It's new syllabus latest edition 2020-21 for KPK textbook board Peshawar. In this tutorial we will solve the questions of exercise 1.4 chapter 1, which is about the matrices. So before starting the solution of exercise questions, let's briefly discuss some background. This exercise is about the multiplication of matrices, in which we will be interested to multiply two matrices with each other. So first we will have to look into the conformability of for multiplication of matrices, that either two matrices are conformable for the multiplication or not. So for example, if we have two matrices A and B, for example, the order of matrix A is M by P and the order of matrix B is, for example, P by N. So it means that this is the number of rows in matrix A, this is the number of column in matrix A, this is the number of row in matrix B, this is the number of column in matrix B. So if the number of column of matrix A is equal to the number of row of matrix B, then they two matrices will be conformable for multiplication. And see, for example, this is the order of matrix A and this is the order of matrix B. So the number of column of A is equal to the number of row of B. So the resultant matrix will be M by N. Mean the order of the resultant matrix will be M by N. So that is the conformability of the two matrices, that either the matrices are conformable for multiplication or not. So the number of column of first matrix must be equal to the number of row of second matrix, then the multiplication will be possible. Then we have the commutative law of multiplication of matrices. So remember that in matrices, if we multiply A with B, it will neither be equal to the multiplication of B with A. Okay, so the commutative law of multiplication of matrices in generally does not hold in the matrices. Okay, mean A multiplied by B is not equal to B multiplied by A in matrices. Associative law under multiplication. For example, if we have three matrices A, B and C, then the multiplication of BC with the A will be equal to the multiplication of AB with C. Mean the associative law of multiplication in matrices is exhaustible. Distribution law of multiplication or addition. It means that, for example, if we have three matrices, then B plus C multiplied by A will be equal to A plus B multiplied by C. So again, it means that let we have A, B and C three matrices. For example, the A matrix is M by N, B matrix is, for example, N by P, C matrix is, for example, also N by P. Then A plus BC multiplied by A will be equal to AB multiplied by BC. Now the question is that the B and C will be of same order. So then the distribution law of multiplication or addition will exist in matrices. Then we have the multiplication identity of matrix. So similar to the additive identity, for example, if we have a matrix and we multiplied with it a matrix I, our I matrix is multiplied with a matrix A, and as a result you get the same matrix, then I matrix will be called the multiplicative identity of matrix A. Okay, and it will be actually the identity matrix of the same order of matrix A. For example, if we have generally matrix A, B, C and D, so then multiplicative identity matrix will be this one. If it is multiplied with A, so you will get the same matrix. That's why it is called the multiplicative identity of matrix. Transpose of a matrix is we have also discussed in exercise 1.2, and here for example if we have a matrix A, B, C, D, for example this is a matrix A, then its transpose is represented by A to the power T, and the rows will be converted into column, mean this AB will be right as like this one, and the another row will be converted into column. So this will be the transpose of matrix A. Verification of the result. Remember, for example, if we have two matrices A, B, and for example if we multiply these two matrices with each other and we take its transpose, then it will be equal to the multiplication of the transposed matrices. Mean if we take the transpose of these two and then we multiply B with A, it will be equal to A multiplied by B transpose matrix. So this will be background of the exercise 1.4. Now let's come to the solution of exercise 1.4. So the question number 1 is about that show that which of the following matrices are conformable for multiplication. So A, B, see A matrix is we can say that is 2 by 1 matrix, and B matrix is 1 by 2. It means that the number of column of A matrix is equal to the number of row of B matrix. So A and B multiplication is conformable, mean A can be multiplied with B. Okay. Similarly, in B matrix we have 2 rows and 1 column, and in C matrix we have 2 rows and 2 column. So the number of column of A is not equal to the number of row of C. So the A multiplied by C is not possible. Okay. Similarly, in A we have 2 by 1 order, and D is 1 by 3 order. So again the number of column of A is equal to the number of row of D. So the multiplication of A with D is possible. Okay, and the resultant matrix will be 2 by 3. Okay, and here the resultant matrix will be 2 by 2. Okay. Similarly, for example, let's check for BD. So the order of B is 1 by 2, and the order of D is 1 by 3. So again this multiplication is not possible. The multiplication of BC, see its order is 1 by 2 and C is 2 by 2. So the number of column of B is equal to the number of row of C. So multiplication of B with C is possible. Okay. Similarly, let's check CD. So in C we have 2 by 2 order, and in D we have 1 by 3 order. So D and C is also not possible. Mean the multiplication of AB, AD and BC, this is conformable. Okay. Remember, in multiplication we are looking into the number of column of first matrix to the number of row of second matrix. If the number of column of first matrix is equal to the number of row of second matrix, then we can say that the multiplication is possible. Okay. Now also we can say that BA, for example, that is 1 by 2 and A is 2 by 1. So again BA is also possible. The multiplication of BA is possible. Okay. And the multiplication of CA, see for example in C is 2 by 2 and A is 2 by 1. Again the number of column of C is equal to the number of row of A. So the multiplication of CA is also possible. Multiplication of BA is also possible. Okay. So these are the possible we can say that the possible conformation. Question number 2, A is equal to this one and B is equal to this one. Now is it possible to find AB? So let's see, the order of A is 2 by 2. The order of B is 2 by 1. So the number of column of A is equal to the number of row of B. So it means that the multiplication of A with B is possible. Yes. Is it possible to find BA? So see BA. So the order of B is 2 by 1 and the order of A is 2 by 2. So the number of column of B is not equal to the number of row of A. So BA is not possible. And find the possible product. So see, only the possible product is AB. So that will be equal to, now remember, the row will be multiplied with column. And here you can see that the A is 2 by 2, B is 2 by 1. So the resultant matrix will be 2 by 1. Okay. Now the first element will be multiplied with this one. So minus 1 multiplied by 3, that is minus 3, plus second element will be multiplied with this one. So 0 multiplied by minus 2, it is 0. Now this row will be multiplied with this column. So 2 multiplied by 3, that is 6, plus 1 multiplied by minus 2, so that is minus 2. Now just simplify it. Minus 3 plus 0, that is minus 3. 6 plus minus 2, that is 4. So that is the possible product. 3 minus 3, 4, and that will be 2 by 1. Okay, its order is 2 by 1. Question number 3. If A is equal to this one, B is equal to this one, C and D, find AB. So AB, see, A is 2 by 2, B is also 2 by 2. So the number of column of A is equal to the number of row of B. So the multiplication is possible and the resultant will be 2 by 2. Now multiply this row with this column. So 4 multiplied by 1, that is 4, plus 1 multiplied by 3, that is minus 3. Multiply this row with the second column. So 4 multiplied by minus 1, that is minus 4, plus 1 multiplied by 4, that is 4. Now multiply this row with this column. So 3 multiplied by 1, that is 3, plus 1 multiplied by minus 3, so that is minus 3. Multiply this row with this column. So 3 multiplied by minus 1, that will be minus 3, plus 1 multiplied by 4, that will be 4. Just simplify it. So you will get 1, 0, 0 and 1. So that is the A product B. Similarly, we have to find out CD. Again, C is 2 by 2 matrix, D is 2 by 2 matrix. The multiplication is possible and the resultant will be 2 by 2. So multiply the row with the column. 3 multiplied by 1, that is 3, plus 4 multiplied by 1 over 2, so that will be minus 2. 3 multiplied by minus 2, so that is minus 6, plus 4 multiplied by 2 by 3, so it will be 8 by 3. Now this row multiplied with this column, so 1 multiplied by 1, plus 2 multiplied by minus 1 over 2, so it will be minus 1. 1 multiplied by minus 2, it is minus 2, plus 2 multiplied by 2 by 3, so it will be 4 by 3. Okay, now just simplify it. 3 minus 2, 1. Here we will get 0. Take the LCM 3, so 3 6 are 18. It will be minus 10 divided by 3, and this will be minus 2 divided by 3. You can solve it and you will get this result. Okay. Question number 4. Let A is equal to this one, B is equal to this one. Find AB. So first see what is the order of A. So it is 3 by 2. What is the order of B? It is 2 by 2. Mean the number of column of A is equal to the number of row of B. So the multiplication is possible and the resultant will be 3 by 2. Okay. So let's find AB. A multiplied by B. So this row will be multiplied with this column. 2 multiplied by 1, 2, plus 1 multiplied by 2, 2. Now this row will be multiplied with this column. so 2 multiplied by 0, that is 0, plus 1 multiplied by 1, that is 1. Okay, now this row multiplied by this column mean this element 3 multiplied by 1, so that is 3, plus 0 multiplied by 2, so that is 0. Now this row with the second column, so 3 multiplied by 0, 0, plus 0 multiplied by 1, that is 0. Now the third row with the first column, minus 1 multiplied by 1, minus 1, plus 4 multiplied by 2, that is 8, minus 1 multiplied by 0, that is 0, 4 multiplied by 1, that is 4. So just simplify it. 4, 1, 3, 0, 7 and 4, so that is A multiplied by B. And does BA possible? See, the order of B is 2 by 2 and the order of A is 3 by 2, mean the number of column of B is not equal to the number of row of A, so BA is not possible. Okay, and AB we have find out. Question number 5, if A is equal to this one, B is equal to this one, then show that AB is not equal to BA. So let's find out AB, mean that is possible. AB is also possible, BA is also possible, but that will be not equal. Okay, so multiply this row with this column, so 1 multiplied by 0, 0, plus 1 multiplied by 0, 0, multiply this row by second column, so 1 multiplied by 1, 1, plus 1 multiplied by 0, that is 0. Now multiply the second row by this column, so again it will be 0, 0, and that will be 0, 0. So the resultant is 0, 0, 0, 1 and 0. Okay, now what will be BA? Okay, BA, so for the BA first we have to write 0, 0, 1, 0, and A matrix is 1, 1, 0, 0. Now let's see the multiplication. So first row with first column, so 0 plus 0, 0 plus 0, mean 0 will be multiplied with 1, 1 will be multiplied with 0. Now second row with first column, again it will be 0, 0, and the next one will be also 0, 0. So the resultant is 0, 0, 0 and 0. Now see, for example, this is matrix 2 and this is matrix 1, so 1 is not equal to 2. It means that AB is not equal to BA. Okay, in the commutative law of multiplication is not existable in the matrices. Commutative law of multiplication. Question number 6, if A is this one, then find A by A. So see, A multiplied by A, that will be equal to just 1, 1, 0 and 0, multiplied by itself 1, 1, 0 and 0. So just multiply the corresponding elements, mean the first row with first column. So the first element of first row will be multiplied with the first element of first column, that is 1, plus the second element of first row will be multiplied with the second element of the first column, so that is 0. Similarly, first row multiplied by second column, so it will 1 plus 0. Second row with first column, so it will be 0, 0. Second row with second column, again it will be 0, 0. So just simplify it, you will get 1, 1, 0 and 0. Okay, question number 7, if A is equal to this one and B is equal to this one, so is AB is equal to BA? So let's see what is AB. So for AB, just multiply the first row with the first column, minus 2 multiplied by 1, that is minus 2, plus 3 multiplied by 2, that is 6. Multiply the first row with second column, minus 2 multiplied by minus 1, so that is 2. 3 multiplied by 4, that is 12. Now second row with first column, 2 multiplied by 1, 2 minus 1 multiplied by 2, that is minus 2. 2 multiplied by minus 1, that is minus 2, minus 1 multiplied by 4, minus 4. So just simplify it, it will be 4, 0, 14, minus 6. Okay, that is AB. Now multiply B with A. Okay, so B with A mean 1, minus 1, 2, 4, multiplied with A, minus 2, 3, 2, minus 1. So just multiply it, first row with first column. So 1 multiplied by minus 2, that is minus 2, minus 1 multiplied by 2, that is minus 2. Now first row with second column, 1 multiplied by 3, so that is 3, plus minus 1 multiplied by minus 1, so that is 1. Second row with first column, so 2 multiplied by minus 2, so that is minus 4. 4 multiplied by 2, so that is 8. Now second row with second column, 2 multiplied by 3, that is 6. 4 multiplied by minus 1, so that is minus 4. Now just simplify it. So minus 4, 4, 4 and 2. So see, that is, for example, matrix 2 and this is matrix 1. So you can see that AB is not equal to BA. Okay, so the answer will be no. AB is not equal to BA. Okay. Question number 8. If A is equal to this one, B is equal to this one, and C is equal to this one, 3 matrices is given, then find AB multiplied by C and BC multiplied by A. Okay, so first find out AB. Okay, first find out AB and see the order of matrix A is 2 by 1, the order of matrix B is 1 by 2, so the number of column of A is equal to the number of row of B, so the multiplication is possible, the order will be 2 by 2. Okay, now just multiply it. So first row with first column, so minus 1 multiplied by 1, that is minus 1. First row with second column, so minus 1 multiplied by minus 2, that will be 2. Second row with first column, so 1 multiplied by 1 is equal to 1. Second row with second column, 1 multiplied by minus 2, so that is minus 2. Now that is AB. Now we have to multiply AB with matrix C. Okay, so multiply this matrix with C. Now both matrices are 2 by 2. Okay, so the first row will be multiplied with first column, minus 1 multiplied by 3, that is minus 3, plus 2 multiplied by minus 1, so that is minus 2. First row with second column, minus 1 multiplied by 1, minus 1, 2 multiplied by 2, so plus 4. Second row with first column, 1 multiplied by 3, so that is 3, plus minus 2 multiplied by minus 1, so that is 2. Second row with second column, so 1 multiplied by 1, that is 1, plus minus 2 multiplied by 2, so that is minus 4. Now see, minus 3 minus 2, that will be minus 5, mean just simplify it, that will be 3, this will be 5, this will be minus 3. So that is AB multiplied by C. Now we have to find out BC first. Okay, BC. So see, matrix B is 1 by 2, matrix C is 2 by 2. So the number of column of B is equal to the number of row of C. So the multiplication is possible and the result will be 1 by 2. Okay. Now multiply the first row with first column. 1 multiplied by 3. so that is 3, minus 2 multiplied by 1, so that is 2. Multiply the first row with second column, so 1 multiplied by 1, that is 1, plus minus 2 multiplied by 2, so that is minus 4, and the result will be 5 and minus 3. Now that is BC. Now multiply A with this BC. So see, the BC matrix is 1 by 2 and A matrix is 2 by 1. So the number of column of A is equal to the number of row of BC. So the multiplication is possible and the resultant will be 2 by 2. So minus 1 multiplied by 5, so that is minus 5, minus 1 multiplied by minus 3, so that is 3, 1 multiplied by 5, that is 5, 1 multiplied by minus 3, so that is minus 3. Now for example, this is matrix 2 and the first one, that is matrix 1. So we have find it out, this one and this one. Determine whether these two are equal. So yes, AB multiplied by C is equal to A multiplied by BC. Now which law of multiplication it show? So we can say that the associative law of multiplication is holding here. Okay, mean the associative law under multiplication is exist. Question number 9. Verify that A into B plus C is equal to AB plus BC for the following matrices. So let's do it for the question number second. Mean the procedure is same. First we have to add B and C. Okay, so B and C will be equal to just add the corresponding element. So 1 minus 1, it will be 0, 2 plus 1, it will 3. Now the order of BC is 2 by 1. The order of A is 2 by 2. So the number of column of A is equal to the number of row of BC. So the multiplication is possible and the resultant will be 2 by 1. Okay. Now A multiplied by A into B plus C. Okay. So just multiply the first row with first column. So 3 multiplied by 0, that is 0, plus minus 1 multiplied by 3, so that is minus 3. Multiply the second row with the column, so 0 multiplied by 0 is equal to 0, plus 2 multiplied by 3, that is 6. Just simplify it. 0 minus 3, that will be minus 3, and 0 plus 6, that will be 6. So this is B plus C into A. Okay, now let's find out first AB. So AB will be equal to 3 multiplied by 1, that is 3, minus 1 multiplied by 2, so plus minus 2. Now second row with first column, so 0 multiplied by 1, that is 0, plus 2 multiplied by 2, that is 4, and just simplify it, so it will be 1 and 4. Okay, now find out AC. So AC will be equal to 3 multiplied by minus 1, so this will be minus 3, plus minus 1 multiplied by 1, so that is minus 1, 0 multiplied by minus 1, so that is 0, plus 2 multiplied by 1, so that will be 2. Just simplify it, so it is equal to minus 4 and 2. Now AB plus AC is equal to, just add the AB and AC, so 1 and minus 4, that is minus 3, and 4 plus 2, that is 6. Now see, for example, this is matrix 2 and this is matrix 1, so both matrices are equal. So it means that A into B plus C is equal to AB plus AC. Mean the distributive law of multiplication or addition is exist here in the matrices. Okay, the similar procedure will be followed for the part number 1. Question number 10. This is the identity matrix. A is this one and B is this one. So find AI. Okay, mean A into I. So that is equal to 5 minus 3 4 6. Okay, multiplied by 1 0 0 and 1. So now just multiply it, first row with first column. So 5 multiplied by 1, that is 5, minus 3 multiplied by 0, so that is 0. Now first row with second column, 5 multiplied by 0, so that is 0, minus 3 multiplied by 1, so plus minus 3. Okay, now second row with first column, so 4 plus 0, second row with second column, so 0 plus 6. Now you can get that 5 minus 3 4 and 6. Okay, so if A is multiplied with this identity matrix, again we get the matrix A, so that is called the multiplicative identity. Okay, similarly you can do it for BI. Okay, mean for example, if this is the matrix B minus 7 3 2 and 8, just multiply with it that identity matrix 0 0 and 1, so you will get that. See, minus 7 multiplied by 1, that is minus 7, 3 multiplied by 0, so you will get 0. Minus 7 multiplied by 0 is equal to 0, plus 3 multiplied by 1, that is 3. Again similarly here you will get 2 and 8. Okay, so if this identity matrix is multiplied with B, again you will get the matrix B. So this is called the multiplicative identity. Question number 11. Prove that A and B is this one. So prove that A plus B whole transpose is equal to A transpose and B transpose. So first just add these two matrices, A plus B. So the addition of these two will be, see, 3 plus minus 3 0, 2 plus 4, that is 6, 1 plus 2, that is 3. Okay, now take the transpose A plus B whole transpose. So just convert the row into column. It will be 0 6 and 3. Okay, for example this is matrix 1. Now first take A transpose, so it will be equal to what? 3 2 and 1. Okay, now take B transpose, it will be equal to minus 3 4 2. Now take the sum of these two transposed matrices, A transpose plus B transpose. So just take the summation. So 3 plus minus 3, it is 0, 2 plus 4, it is 6, 1 plus 2, it is 3. So for example this is matrix 2. So the matrix 1 is equal to matrix 2. It means that A plus B whole transpose is equal to A transpose plus B transpose. Okay, and similarly it will be applied for this one, that A minus B whole transpose is equal to A transpose minus B transpose. Just look into it, that A minus B is equal to 3 minus minus 3. 3 minus minus 3, it will become 6. 2 minus 4, it will become minus 2. 1 minus 2, it will be minus 1. Okay, now take the transpose. So A minus B whole transpose is equal to 6 minus 2 and minus 1. Okay, for example this is matrix 1. Now see, here already we have taken out the transpose of A and B. So now just take A transpose minus B transpose. Okay, take the difference. So see, 3 minus minus 3, it will become 6. 2 minus 4, it will minus 2. 1 minus 2, it will minus 1. So see, suppose this is matrix 2. Now the matrix 1 is equal to matrix 2. So it means that A minus B whole transpose is equal to A transpose minus B transpose. Similarly, procedure will be applied for the second question. Question number 12. If A is equal to this one, B is equal to this one, then show that AB whole transpose is equal to B transpose and A transpose. Okay, B transpose and A transpose. So first we have to find out the product of AB, and then we will take the transpose. So see, AB will be equal to the first row with first column, so minus 2 plus 10. First row with second column, 2 plus 15. Second row with first column, minus 3 multiplied by minus 1, that will be 3. 4 multiplied by 2, that will be 8. Now second row with second column, so minus 3 plus 12. Just simplify it, so it will be 8, 17, 11 and 9. Now take the transpose, AB whole transpose. Okay, so that will be equal to 8, 11, 17 and 9. For example, this is matrix 1. Now take B transpose. B transpose will be equal to minus 1, 2, 1, 3. Take A transpose. Okay, so it will be equal to 2, minus 3, 5 and 4. Now take the product of B transpose into A transpose. So it will be equal to first row with first column, so minus 1 multiplied by 2, that is minus 2, plus 2 multiplied by 5, that is 10. First row with second column, minus 1 multiplied by minus 3, so that is 3, plus 2 multiplied by 4, that is 8. Now second row with first column, so 1 multiplied by 2, that is 2, plus 3 multiplied by 5, that is 15. Second row with second column, 1 multiplied by minus 3, so that is minus 3. 3 multiplied by 4, so that is 12. Now just simplify it, so it will be 8, 11, 17 and 9. Okay, for example, this is matrix 2. So matrix 1 is equal to matrix 2. It means that AB whole transpose is equal to B transpose into A transpose. Okay, now for the second part, first we have to find out the C transpose. So the C transpose will be AC and BD. Okay, now again take the transpose of this transpose. Take the transpose of this transpose. So it will be equal to AB and CD, which is equal to the original matrix C. Okay, so if we have a matrix and if you take its transpose and then take the transpose of that transpose, it will be equal to the original matrix. Okay, here again we have matrix A and we have matrix B. So A matrix is, look into it, that is 2 by 3 and B matrix is 3 by 2. The number of column of A matrix is equal to the number of row of B matrix, so the multiplication is possible and the resultant will be 2 by 2. So first you have to find out A multiplied by B, then take its transpose, then take the transpose of B and take the transpose of A and multiply B transpose with A transpose. So you will see, you will look that AB whole transpose will be equal to B transpose to A transpose. Remember here that is B transpose and this one is A transpose, mean AB whole transpose is equal to B transpose multiplied by A transpose. Okay, that is the formula which we have to prove, okay, in this question. So this was all about the exercise 1.4. Thank you for watching. Subscribe the channel for more videos, and comment if you have any question or suggestion, and share with your friend. Thank you.